Hello everyone. Myself Kiran Kadakuntla, lecturer, Department of Electronics and Communication Engineering. Today we are dealing the session 9, that is IC voltage regulator of unit 1 power supplies. Okay. So in the previous session we have discussed about the Zener diode as a voltage regulator. So we understood what is meant by voltage regulator, and then we understood what is the how we can use the voltage regulator by using the Zener diode. Okay. So in that session we have discussed how we can use the Zener diode as a voltage regulator, and we understood what is line regulation and what is load regulation. Okay. And how we can use the Zener diode for line regulation purpose and load regulation purpose. And later on we have discussed some problems based on the same line regulation and load regulation, and we have gone through some multiple choice questions, and I hope you understood the topics in the previous session. Okay, so coming to today's session, in today's session we are discussing the IC voltage regulator. Okay, so the difference between the previous topic and this topic is, here also we are dealing with the voltage regulator. The concept remains same, only the difference is here we will be using the IC for regulation purpose. Okay, in the previous topic we have seen how we can use the Zener diode for the regulation purpose. Let's start with the topics. Okay, in this IC voltage regulator concept we will be discussing these points. First we will understand what is meant by IC voltage regulator, that means its introduction. Then we will see what are the classifications of IC voltage regulator. Then in the classification we will see the features of 78XX IC. Okay, then we will see the features of IC 79XX, and we will understand what is meant by XX and 78 and all in this session. Later on we will discuss applications of IC 78 series and 79 series. At the last we will be dealing features of IC LM317 and its uses. These are the topics we will be covering in today's session. Okay, let's begin with the introduction of IC voltage regulator. Okay, so this is the IC voltage regulator diagram. First, before going to this diagram, we should remember the regulator concept. So we know that in the complete power supply sections where regulator fits, we just will revise the complete DC regulator power supply system. First, we will be down converting the AC voltage by using the step down transformer. Then we will feed it to the rectifier, which will convert your AC to DC, and but it will be having the pulsating DC, means it will be having the ripples. Then we will feed it to the filter for smoothing purpose. Then that output will be fed to the voltage regulator. In this diagram you can see directly we have taken the output of the rectifier and filter. Okay, so this is the section of a power supply which has a rectifier followed by the filter. So output of the filter is smooth, but it is not constant, so we need to regulate this supply so that we can feed this voltage or supply this voltage to the our electronic instruments. Okay, so in the IC voltage regulator we'll be taking the output of the filter of a power supply, then we feed into the IC voltage regulator. Normally in this you can see IC voltage regulator is of 3 pins. Okay, even we have some different kind of IC voltage regulator. Normally we see the 3-pin IC voltage regulator. In that it will be having the one input point, one is output point, one more is a ground point. So input point means where it will take the input signal, and it internally it will be regulating the power supply, and it will be feeding it out or sending it out or supplying the output voltage, constant output voltage to the load. And this ground will be connected commonly between the input and the load. So this is the introduction of the IC voltage regulator. Okay. Now we will see the classifications of IC voltage regulator. Means how we can classify the IC voltage regulator. Here we will be having the classification based on the various things, like first based on the terminals used, means how many terminals the IC voltage regulator has. Based on that we will be having the classification, that is 3-pin IC voltage regulator, and one more is a 5-pin or IC voltage regulator, or more number of pins IC regulator, means it will maybe having the more than 5 pins. So based on the number of pins also we can classify the IC voltage regulator. Then we have one more classification of IC voltage regulator, that is based on the output voltage. Okay, this classification is very important. This is only based on the number of pins available in the IC, but here it is mainly on the output voltage. So in the voltage regulator, the output voltage is very important. So this classification has a more importance. In the this kind of a classification, we have a three types. One is a fixed output voltage regulator, and second one is a variable or adjustable output voltage regulator, and the third one is switching regulators. Okay, these are the three types of IC voltage regulators available. So these are the classification of IC voltage regulator. Okay, now we'll move to the next topic, that is a what is mean. Now we will understand what is mean by fixed voltage regulator, what is adjustable, and what is a switching regulator. More or less, the with the name only we'll understand the concept. Okay, there is not a big thing to analysis about it. Fixed means what? Normally we know that fixed means which will not vary, which is having the fixed value. Okay, fixed voltage regulator, the name itself indicates that it will be providing the fixed voltage. So where all you will get the fixed voltage? Generally in the battery, if you say it's a 1.5 volt battery, it's a fixed or variable. It's a fixed because you'll be getting the 1.5 volts continuously from that battery. If you say it's a 9 volt battery, that means you will be getting the 9 volt continuously. So that will come a 9 volt battery. These are all the batteries what we have seen, it's a fixed voltage only. But here we are dealing with a fixed voltage IC regulators. Okay. So these are not the battery or anything else. It's a regulator made by a IC. So fixed IC voltage regulator, a fixed voltage regulator produces a fixed DC output voltage, which is either positive or negative. So remember this. So means either it can provide you the positive or negative. Okay. It's based on your requirement. You can go for a particular kind of a fixed IC voltage regulators. So mainly example of fixed voltage IC regulators are IC 78 series and IC 79 series. XX indicates the voltage level. Okay. Next, we will understand the 78 series and 79 series in detail. So briefly, you can understand right now that is a XX means it's a voltage levels, and 78 and 78 and 79 has its own meaning. We'll discuss that. So this is the first type of a classification. In that, the one more is a adjustable voltage regulator. So what is meant by adjustable? Where we can vary. So simple example like you might have seen the adjustable pot or the fan knob. In a fan knob, we can see that we can adjust the speed of the fan, correct? So similarly, here the adjustable voltage regulator means where we can changes the voltage. In many cases, it may require that we may have to, we may need a different voltage levels. Sometime I may need a 5 volts, sometime I may need a 10 volt, 15 volt. So as per my requirement, that voltage requirement may vary. In that case, the fixed voltage regulator may not be helpful to us because it will be providing only one fixed value. In even we can get it from the fixed voltage by using the different ICs of a different values. But in adjustable, using the single IC only, we can get the different voltages. So that is adjustable voltage regulator. Let's go through definition. An adjustable voltage regulator produces a DC output voltage which can be adjusted to any other value of certain voltage range. Example of this kind of IC is LM317. So this is a one adjustable voltage regulator. Just you can compare this with your fan regulator. In a fan regulator, we'll change the position of the knob so that the speed of the fan will be changed. So this is one more type in the this classification. The third one is a switching regulator. So first one we have seen the fixed, second one is adjustable, third one is a switching. In this, it will be having the control element which operates as a switch. Okay, and it will be providing the higher efficiency compared to your linear voltage regulator. So it has its own advantage compared to the other linear voltage regulators. So as the name indicates, switching means it will be having the switching operation, and that will be done by using the control element. We will discuss this topic in detail later on. Here just we will understand that it has a control element which operates as a switch and it provides a higher efficiency. So these are the three classifications we have discussed based on the output voltage. That is a fixed voltage, fixed output voltage. One more is a adjustable one, and the third one is a switching regulators. Now we will start discussing the ICs of fixed voltage regulator. So when I was discussing the fixed IC voltage regulator, I told you the example of IC 78 series and IC 79 series. So we'll start discussing the IC 78 series. So in a fixed voltage regulators, we have a 78 and 79 series. 78 series gives us the positive output voltage. Remember, 78 series gives us the positive output voltage and 79 series gives us the negative output voltage. And this XX indicates the value. Let's say example, if it is a 7805, 78 indicates a positive and 05 indicates the value of the output voltage. 7805 means it's a positive 5 volt output it will be providing. Similarly, uh, you can take it for the 79 series. 79 series for the negative output voltage. Okay. So see the diagram. So this is the IC of 78XX. One more thing, it will provide you the positive, and provided the input must be positive. You cannot give an input voltage negative and expecting the output voltage positive. Okay. But the only thing is, if you have a more amount of input voltage, it will be providing with a fixed output voltage. That is the advantage of this 78 series IC regulator. Here you will be feeding the, or you will be supplying the positive input voltage. It must be higher than your output voltage required. Then it will be given to your input point. Then here we have a one ground. In the 78 series, it will be providing us the constant positive output voltage that will be taken from the output pin. So you can see how many pins it has. It has a 3 pins. Here in this diagram, you can see the IC structure. It's a 78 series. See how it is showing. From the left, if you are taking, it's a supply. It's a V in pin number 1. That is this point. Second one is a ground. This one. And third one is a output voltage. So this is the output voltage. So this is the diagram of IC78 series. And you might think, what is the meaning of this CI and C naught? Okay, CI means input capacitance and C naught means output capacitance. So in a Zener diode concept also we have discussed, why we are in a filter concept also we understood why the input capacitance and output capacitance are used. We know that we are dealing this for the DC. If there is any AC content available, it has to be removed. That will be done by using these capacitors. Suppose say whenever you have some input, if it has some AC content, what happens? We know the characteristics of this capacitor. It will block the DC, but it will allow AC to pass. Means if there is any content of AC here in the input, it will be bypassing to the ground, because capacitor allows the AC, it will bypass to the ground, and that will not flow to the output side. Means we are eliminating the AC content in the supply voltage. Similarly, in the output also same. If there is any AC content presence in the output of this series, 78 series IC, that will be bypassed to the ground. By this, at the output side, you will not be having the AC content. So this is the 78 series IC and its internal structure. Now we will see what are the features of a IC78 series. Features means what is its voltage output values, what is the current rating. Okay. Now we understood some features, that is it is of 3 pins. Okay. And 78 series, I already told you, 78 series means a positive. XX indicates the voltage levels. So let's go with its features. The 78XX ICs have 3 pins. Yes, we have seen that it has a 3 pins. What are those 3 pins? Input point, input terminal, output terminal, and the ground. These are the 3 terminals. And then the 78XX series are fixed positive voltage regulator. Remember, it is a fixed and positive voltage regulator. You cannot get the negative from the 78 series. And XX is replaced with the 2 digits indicating the output voltage. So I told you XX indicates the output voltage. If it is a 0.5, that means output voltage is 5 volts. If it is a 1.2, that means output voltage is a 12 volts. Okay. And output voltages of 78 series are 5 volt, 6 volt, 8 volt, 9 volt, 12 volt, 15 volt, 18 and 24. See, these are the available ICs in the 78 series. You should remember these, because if you are doing any project or any circuit where you need some fixed voltage, then it will be helpful. Say if you want a fixed 9 volt output voltage, okay, and you don't want to use the battery because it needs a replacement or recharging. If you want to fixed power supply for 9 volt, even you can use a 7809, because here only you can see this is available. These are the available 78 series IC voltage regulators. Okay, so it is starting from 5 volt to the 24 volt. This is the range you can get the output voltage in the 78 series. These devices support an input voltage from around 2.5 volts up to maximum of 35 to 40 volts. So when you are applying input, remember it must be positive. So what is the range of input what we can apply? It is ranging from 2.5 voltage to maximum of 35 to 40 volts. This is the voltage what you can apply. And the last point, typically it provides 1 to 1.5 amperes of current. It is a current rating of this IC. It provides you the 1 to 1.5 amperes of current for the load. So these are the features of IC 78XX or 78 series. And we have still more features, that is a 78 series IC have a built-in protection against overheating, short circuit, and the regulator always operate in a safe operating area. It means sometime it may happen that it may overheat or it may have short circuit problem. In that case, these ICs comes with inbuilt protection. That means if there is any overheating, automatically it will take care of it. Similarly for short circuit, and it normally operates for the safe operating area. Means it will be in the safe zone, it will be operating. It will not go beyond that safe zone so that it will not get damaged. Okay. So these are the features of IC 78XX. Now we'll deal IC 79XX. So it is more almost similar to 78 series. Only the change is here 79 indicates a negative voltage. In a 78 it was indicating with a positive voltage, and it is indicating with a negative voltage. And remaining all the things are same. See the diagram. We have input point here, output point here. It is also having the three terminals: input, output, and ground. Input will be fed to this input pin, and internally it will be maintaining the fixed output voltage, and it is a 79 series. It will be giving you the negative output voltage that will be taken to the load. This is the pin diagram of IC 79 series. It has a 3-pin: ground, input, output. So you should remember one more thing, how you have to check the pin number. Okay, here see, if you are holding in this position, how it is shown in this diagram. If you're holding in this position, keeping the legs down and facing this number in front of you, facing towards you, in that time the left terminal is a ground, center one is the input, and third one is the output. So in before we have seen the 78 series, there it was different. Okay, so remember how you have to check the pins in the 78 series and 79 series. And in the previous topic only we have seen what is the need or the necessity of these capacitors. Okay, so this is a 79 series. So let's see some features of 79 series. Let's go through this. The 79XX is a negative voltage regulator. Fine, because 78 is a positive and 79 is a negative. XX is replaced with a 2 digits indicating the output voltage. Fine, so this XX indicates the voltage levels, and output voltages of 79XX are 2 volts, 5.2 minus 5.2 volt, minus 5 volt, minus 6 volt, minus 8 volt, minus 9, minus 12, minus 15, minus 18, and minus 24 volts. So these are the voltages available at the output side. Okay, these devices support an input voltage up to maximum 35 volt. Means you can apply up to 35 volts to the 79 series ICs. Okay? And it has a capability of supplying current rating of 1.5 amps. Okay, up to 1.5 amps current it can supply, and it employs the built-in protection against all the overload conditions. So even in the 78 series, we have seen that it internally it has an inbuilt function of having the protection. Okay, if there is any overload, automatically it will have a protection. Then high ripple rejection means if there is any ripples, it will have a higher ripple rejection. Means the output will be having the very ripple free output. So those are the features we have discussed about the 79 series. Now we will see the applications of IC 78 series and 79 series. Due to their ease of use and low cost, 78 series and 79 series have been used in ATX power supply of SMPS. So right now you may not be knowing what is meant by ATX, or at least you know what is meant by SMPS. So SMPS means switch mode power supply. In your computer, in a CPU, it will have a SMPS which will be providing you the different voltages to the different subsystem of the computer. It may be your hard disk drive or your CD drive, floppy drive, or any other uh, part of a computer. It will be providing the power supply. That is the SMPS. ATX power supply means advanced technology extended. Okay, that kind of a power supply of SMPS will be using this 78 series and 79 series ICs, and it will be used in the fixed voltage regulators, and it will be used in the laboratory regulated power supply. So in a laboratory also, we will be using these ICs to get the fixed voltages. Okay, so these are the applications of 78 and 79 series. Now IC3 LM317. So earlier we have discussed the classification as adjustable voltage regulator, means where we can changes the output voltage. Till now we have discussed the fixed, where you can obtain only fixed value. If I want a variable or adjustable voltage, then I have to go for this kind of a ICs. So IC LM317 is a adjustable voltage regulator. This is the its diagram, and this is the its IC pin configuration. It is also of 3 pins. It has a 3 pins. One is a V in, one more is a V out, and the third one is a adjust. So adjustable means compulsorily we need to have some adjust pin where we can change the required output voltage. Let's go through its diagram. Here it is have a positive input. Okay, input will be supplied to the input pin, and it will be having the regulation part internally, and from the output pin you will be getting the output, and adjusting the output voltage is possible using these two resistors R1 and R2, and this voltage will be given to the adjust point or adjust input of the LM317. You can see we have two resistors R1 and R2. So R1 is a fixed resistance and R2 is a variable resistance. So we can change the value of R2, that will changes the output of the LM37 IC. Okay, so R1 and R2. Next we'll see the equation how exactly output is dependent on R1 and R2. Okay, so in this adjustable voltage regulator, which is a changeable element, that is a resistor R2. So now we'll see the features of IC LM317. So IC LM317 voltage regulator IC has a 3 pins. So it's a 3-pin IC, and the adjustable positive voltage converter, it is operating for the positive voltage. Remember, you cannot use this for negative. It is adjustable positive voltage converter. It provides an adjustable output voltage range from 1.25 volt to 37 volts. See the range, it has a very good range from 1.25 volts to 37 volt. So you can use this IC for the large range of voltage levels. This IC can supply a load current of up to 1.5 amperes. IC LM317 employs built-in protection even adjust terminal is open. Means if you have kept the adjust terminal open, then also it will have its own protection. Okay, it has a built-in protection like as we seen in the other two fixed voltage regulators. Here also it has a built-in protection. Then minimum and maximum input to output voltage difference is 3 to 40 volt respectively. Recommended is 15 volt. It is a input output voltage difference. Okay, means what is the difference it may have between the input to output. It is from 3 volt to 40 volt. Means let's say 3 volt means input will be 5 volt and output you are expecting that 2 volt. So what is the difference? 3 volts. Similarly, maximum how much difference it can have? 40 volts. Let's say example, input is 40 volts, and you are taking only the input is 45 volt and you are taking only 5 volt, okay, as a output. So what is the voltage difference? 40 volt. So this is the minimum and maximum input and output voltage difference, and normally recommended is 15 volt. Means 15 volt difference you can have. Then output voltage is given by V naught equal to V reference into the bracket 1 plus R2 by R1. So output is dependent on V reference and these two values. Here the V reference also fixed, R1 is value also fixed, only R2 is adjustable. So the directly R2 is having the influence on the output voltage. Because V reference and R1 are fixed, how you change the R2 value, that will change your output voltage. So this is the output voltage of a IC LM317. So coming to the applications, where all you can use the IC LM317, it can be used for battery charger circuits. Okay. So then variable power supply, motor control circuits. We have many more applications of LM317 because in many applications we need a variable power supplies where you can adjust the supply. Okay. So these are the applications of IC LM317. So these are the topics we have discussed today. So let's revise what are the topics. First, we'll see some assessment questions. So assessment question for you is, first one, compare LM317 with IC78XX and IC79XX. It mean to say that you have to compare your adjustable regulator to the fixed voltage regulators. You can make a comparison table between the LM317 and the 78 series and 79 series ICs. So we can write down many differences. So mainly it's a fixed, it's a adjustable, and this is voltage range of LM317 and 710 79 series voltage regulators, current rating, built-in productions, applications. Okay, so these are the many things and advantages and disadvantages. Okay, even you can think of advantages and disadvantages of each kind of a ICs that you can write down for this assessment question. Second question is, list the features of IC LM317. So we have discussed the features of 78 series, 79 series and IC LM317. So the assessment for you is to list the features of IC LM317. Okay, one more question, state true or false. So tell me whether it's true or false. IC7805 is a plus 5 volt voltage regulator. So is it a right answer or wrong answer? So you might have got the correct answer. That is a 78 series indicates positive and 05 indicates the voltage level. 7805 means it's a plus 5 volt. So it's a correct answer. So second one, the output of 79XX is always positive. Is it correct? So if you remember the 78 series and 79 series function, you can easily guess that 79 series is not meant for positive. It is meant for negative voltages. So this statement is false. Okay. So now we'll see some multiple choice questions. First, I'll read out the question and I'll give you some time. You can answer. Okay. If you're not getting the answer, I will explain it. The plus 12 volt is the output of, options are IC7912, IC7805, IC7812, IC LM317. So here it's showing the fixed output voltage. Now, which one is the correct answer? See, first you have to think that here it is given as a fixed voltage. They are not given any range of voltages from here to here the output will be. So it is fixed voltage regulator. That means you can only these three. LM317 is not a correct answer because it is a adjustable. Now it is a plus. So plus means which IC will be using 78 series or 79 series. So it's a 78 series. Okay. So option may be B or C. And the value given is 12 volt. So here you can see B option is having 0.5 volts and C having the 12 volt. So which one is correct? Option C is a correct. IC 7812. Okay. Let's move on to the next question. What is IC LM317? So what is this IC? Let's see the option. First one, an IC voltage regulator. Second one, a full wave rectifier. Third one, a half wave rectifier. Fourth one is an op amp. So what is IC LM317? So is it a rectifier? No. So it's not a full wave rectifier. It's not a half wave rectifier. Is it op amp? No. It's a IC. That is an IC voltage regulator. So correct answer for this question is 2A. So the third question is, a voltage level range of the LM317 adjustable voltage regulator is. So what is the voltage range? That is they are asking. Let's see the option. That's a 0 to 5 volt, 1.2 volt to 37 volt, minus 5 volt to minus 24 volt, 5 volt to 24 volt. So what is the voltage range? We have discussed this during the explanation of LM317 IC. So what is the correct answer? And remember, this will operate only for the positive voltages. So the option C is not a probable answer. Okay, so because it has having the negative voltages. So got the output or got the answer. Which one is the correct answer? So correct answer is the option B, 1.2 volt to 37 volt. We have discussed that it is dealing with the large range of voltages, that is 1.2 to the 37. This is the correct answer. So this is the topics for the today's session. Let's just revise what are the things we have covered today. Today, the topics we have discussed are, so remember, so we have discussed about the regulators, fixed voltage regulators, adjustable voltage regulators, and switching regulator. Just for switching regulator, we have seen only the definition. And in fixed voltage regulator, we have seen what is 78 series IC in its structure, 79 series and its structure. Then in the adjustable, we have seen the LM317 ICs. Then we have gone through some questions, and we have given some assessment for you to try at home. Okay, so this is regarding the session 9. Thank you.